Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by treating E as the base of natural growth. You'll compute it and see why it appears. First, pick n values, 10, 100, 1, 0, 0, 0. Calculate 1 plus 1 slash n, and observe the values approach about 2, 71,828. Once done, compare the increments between n steps to understand convergence speed. Make sure to note that larger n give diminishing changes. This shows why calculators use series instead of brute force limits for high precision. You switch to the power series because it's efficient and explains why EX is special. Sum 1 slash k, from k equals 0 upward and stop when the next term is below your tolerance, for example 10/6. This gives rapid convergence. Note that factorial growth shrinks terms quickly. Once you have E, extend to EX by summing xk slash k, which also leads directly to the fact that the derivative of EX equals itself. That's why E models continuous proportional change so naturally. You finish by applying E to real problems. Compute continuous compounding with A equals P ERT or model decay with A equals P EKT. Once you set parameters, invert with natural log to solve for time, t equals 1 slash r, ln, a slash p. Make sure to keep units consistent and watch signs in exponents. If values behave strangely, check series truncation or floating point overflow. Rerun with higher precision or smaller step sizes, and verify you didn't flip a sign or use base 10 log instead of natural log.
Thanks for watching. Subscribe to keep your life in tune.